we've got our pitch competition here. Thank you for all sticking with us. I'm also very impressed with the crowd. I haven't been in a group like this in a while, so this is exciting for me to do this. I want to talk to you about the Innovation Challenge experience briefly. So what we've got here with these pitches is we're bringing people in, providing them the data, the technical resources, helping them formulate their pitch and attract investors. That's what NextCycle is all about. And it really is different from the traditional grant making process where you fill out the RFP, you send it in, you hope that it gets done. And that's from an Eagle perspective. This is helping us also get higher valued projects and do the work that we all know needs to be done, which is leverage those investments. So hearing Jennifer Louie make the announcement of a $5 million investment for Michigan, which is pretty amazing, is exactly the type of work that we're doing here. We're taking our limited resources and your limited resources, and we're putting them all together to make enough resources to get the job done. So that's what the innovation track experience is all about, bringing those investors, state investment, private investment, local, nonprofit, bring it all here. And so we also gave a lot of thought about the types of teams that we wanted. So we wanted innovation, we wanted sort of the new, because we knew that that was going to be really important to attract the investment to Michigan, to put Michigan on the map. But we also knew that road technology and organics was key. We knew that the supply chain, from the curb to the end product, was really important. So that's why we designed those as well. But today we're going to hear from one of the tracks, which is the recycling innovation technology. To do that, to kick us off here, JD Lindenberg is going to run through the pitch process for you. JD is with Resource Recycling Systems, and we've worked together for many years. He brings a level of expertise unmatched because he has done this work, supported teams, and he gets in there. And I went out to Colorado and saw a pitch session that he ran with Megan and the crew over there. And it was really fun to listen to his questions. So you've got JD here who really asks good questions. So I'm hoping the panel here, the judge panel, is thinking about all the tough questions that it makes it more dynamic and interesting to have those questions heard. So JD, come on up and let's do this. I welcome you up here to the, make sure you stand here so they can see you online.
Oh, okay, there's rules. Thank you for letting me know. Well, we're gonna kick this off. Unlike the showcase where they had the super flexible 8 minutes, these ones have 5. So we're gonna tighten them up even more. So we're gonna watch people see how they perform under pressure. And one other thing that's really cool, and this is the first time we've been able to do this with our NextCycle venture, because as Matt mentioned, we've been doing it in Colorado for a couple of years. We have some prize money at the end that's going to be awarded. And for the best pitch, there's going to be a $16,000 prize for that. And there's going to be a couple other people's choice and some services from Centropolis that will also be awarded. So I'm really looking forward to that. It's really exciting. And let's get going. We're ready to go with the first team. We believe it's going to be online. It's Sabermetrics. Let's welcome Harjit Bajaj. Harjit, did I do that right?
Yes, sir. You got it perfect.
You can speak now. I'm going to mute it so he's a speaker.
Hi, I'm sorry, I don't actually hear anything. Should I be starting?
All right, we can see you and your slides, so feel free to start.
Okay, perfect. Thank you. Okay. My name is Harjeet Bajaj, founder and CEO of Sabermetrics. Have you ever been in a situation where you've had a avocado that you bought from the supermarket and you placed it in your fridge, and 5 days later it never ripened? Or you bought red delicious apples and you brought them home and bit into them, they were anything but that. Or bananas that you bought that were perfectly yellow, but by the time you got home and took them out of the trunk, they started spotting. This is an issue that is faced by consumers and also the food and ag businesses as well. So I'm talking about growers, distributors, processors, and retailers not having a good sense of the shelf life or the quality of the food product that they're moving through the supply chain. Due to this poor ability to do quality assurance and quality control, food and ag businesses lose about 15 to 20% of their inventory. That's a major, major hit. The ability to provide real-time quality assurance, quality control, such that these businesses have metrics like shelf life or quality drift or contaminant detection provided to them with a touch of a button, and they can make a smart procurement, inventory movement, or processing decisions. That is a $60 billion market opportunity that remains mainly untapped. Now, enter Sabermetrics. We've got a solution in place that these various different members of the food supply chain are using today. We provide them with sensors, either they're inline or tabletop or handheld. And the data that we pull from the food item itself, these sensors will capture the biochemical and biophysical features from the food item. They will send it to a AI framework, our AI framework called Dr. Sam in the cloud. Dr. Sam then correlates those chemical and physical features into insights, meaningful insights like shelf life and quality drift or identifying contaminants, those sort of elements. The output of that then is presented on a screen to the customer. In doing so, we're able to help reduce the amount of inventory loss by up to 70%, which is a major savings for these companies, many of whom operate on a very small 1% profit margin. Our business model is very simple. $5,000 to $25,000 per year in subscription fee model, 5-year opt-out. Depending on the customer, we like to make sure that they have a 3-month payback period, and our prices range within this level. Our go-to-market strategy has been, up until now, based on word of mouth or being part of certain strategic initiatives that give us that pull demand. And we've done very well with being cash flow positive and profitable right from year one and have generated significant revenue. Going forward, we've established meaningful partnerships with industry leaders that are going to become our distributors. We have significant competitive advantage compared to our competitors. You see the 7 different attributes on the top there. The device had to be ultra affordable, non-destructive, real-time in situ results, no chemical prep, 6-month payback or less, predictive. The metric should be predictive, not just detect, tell us before it happens, accurate and precise. We didn't guess these, we asked them, and we built our devices to address these. Lab tests can't do that. Near-infrared devices can't do that, and definitely manual inspection can't. And believe it or not, most of the members of this within this industry have a lot of high turnover staff that are touching, feeling, squeezing, smelling inventory and making decisions on billions of dollars worth of inventory that way. So it's no wonder that they lose so much in inventory, 15 to 20% of their inventory. We're really proud to be a social enterprise, one that balances financial ROI, we are for profit, with social ROI metrics at our board level. We like to monitor and assess how much of an impact we're making on a reduction in GHGs, reduction in usage of water, and also on human health as well. And because of this, we have won quite a number of awards, recognized by Sustainable Development Technology Canada for our ability to reduce the amount of energy required of food processors by using our QA/QC devices. Top 20 startups in Canada, CX20, deep tech pioneers out of 5,000 companies. Startup of the year, I'll stop bragging. Our senior management team is presented here, but it really doesn't do our team a service. We've got a very small but very powerful team of experts that have built systems, AI systems in their previous lives that are in space or are being used in the medical industry. So a very powerful team. And our ask is $10 million in this next round that we're raising in the next 3 to 6 months. Half of it we've secured as non-dilutive, and we also have our current investor, which is they're the third largest software company in the world, very aggressive in the food sector, that will also invest. And we're looking now to see if we can find other non-dilutive and dilutive options to round this out. We're very interested in the Michigan area. That's where we're going to now grow the team because of the talent that's available there, plus the fact that there is a lot of the food and ag business that takes place within that region. So definitely that is going to be a location out of which we will build not just our US operations, but
We need to wrap up. Thanks. I think we have one question. We've got a question from one of the online judges, Prem, who inquired, Harjeet, if you wouldn't mind commenting on, walk us through a use case for one of your target markets about how sabermetrics could be, sold and implemented within the industry.
Okay. So I'll give one example of a food processor that uses our technology to be able to assess in real time the quality of French fries. So they're the largest French fry manufacturer in the world. They are able to detect not just defects like browning, sugar tips, and internal textures, a taste quality feature at the end of the line, but in midline, we're able to show a quality drift that's starting to take place. They take that information in real time and they make changes to their processing parameters so that the product stays in spec. That has helped them to reduce their out of spec product by 70%.
Thanks. Do we have time for another question? Yes, anybody, any of the judges in person wish to ask a question?
As a clarification, this is for food processing, so the manufactured products. That it would not be considered like a competitor to Lean Path in the food service space.
Sorry, can somebody repeat the question? I wasn't able to.
The questioner asked whether, was this specifically aimed at food processing, or are you in the retail space and competing with Lean Path?
We are providing products to retailers, food processors, distributors, and also to vertical farms, to growers as well.
I think that it's time to move on to the next. Thank you very much, Harjeet.
Okay. Thank you.
Moving on to North Dakota, West Michigan. Brian, the floor is yours. Thank you. People put in their applications, they move through the selection process. Once they were selected, they part of the channel class, as it were. We match them up with specific internal expertise. So I'll keep going. We'll get through the whole process.
Thanks, JD.
Go ahead, Brian.
Hey, good afternoon, and thank you for this opportunity. I'm Brian Spicer, Chief Business Officer and co-founder of Innovaco. And I'm here representing a team that's been working on a problem, solving a problem that majority of people don't even know exists. A problem that a lot of manufacturers of goods, the products that we have in our homes and our offices all over and how we get there, they use. A problem that they all have that we as Innovaco are working to solve. You might be asking yourself, what is that problem? What's in common that they have? It's powder coating. It's an industrial paint that's used in industrial applications all over the globe in all different applications. The Innovaco process is working on capturing the overspray that is generated during this process. Powder paint starts in a dry powder form, and when it's applied to the product that does not stick is collected, and that is typically called overspray. That product is transported all throughout the world to landfills all over. That's the same product that Innovaco is recycling. So, why don't large users of this product reclaim this material and use this themselves? Even though the technology exists for them to do this, they don't, because of technology advances of quick color change and lean manufacturing practices has led and changed the manufacturing from days where we went long conveyors of black products for days in a row to now where we're doing order by order by order. It's generated this large amount of massive waste in the industry that is present being landfilled all over. It equates to upwards of about 50% of everything that's manufactured is landfill. This equates to about 2 billion pounds everywhere, every year that we burn or bury, every year. So as we decide to dive deep into this problem, look into it, it's no wonder that a large majority of the problem resides in the Midwest. When we look at the United States, we think of legacy manufacturing that has started in the Midwest, in Michigan specifically. We look at the automotive industry, we look at the office furniture industry, industrial industries that are here within Michigan and the Midwest have a huge presence and a huge problem in generators of this waste. We estimate that upwards of 40 million pounds could end up in Michigan landfills each year. That does not count the packaging that contains the 40 million pounds and all the transportation that's going from manufacturing facility to landfill. Go back. Strategically located in West Michigan, we have the first recycling facility located, and we have the capacity to reclaim and divert 10 million pounds annually each year right within Kent City, Michigan. Our team has developed the technology that allows us to consistently make premium powder coatings using only waste raw materials. And because we do not use virgin raw materials, the cost of our finished goods are significantly lower, and the significantly reduction in the greenhouse gas emissions. Because we use a circular process and we use a closed loop circular economy, our products has passed all of the specifications that all of our customers have set forth for us, and that's visual, and that is performance specification, durability, visual, things like that. Our roadmap. As we begin to fulfill our initial contracts and others within the same industries are showing deep desire to work with us, we can only think about the future and the adaptation of our technology and what that looks like. As our technology gets more exposure and the reasons for that circular programs do, so will the need to operate our equipment, maintain our equipment, and grow our business. With our current growth in our current sales pipeline, we project to hire 6 more individuals onto our staff within the 6 months to fulfill existing contracts that we have and upcoming contracts that we're presently negotiating. Yep, this is the last one. Our team has over 70 years of experience, and specifically in the powder coating industry. That is why we are uniquely qualified to identify a problem that no one else has seen, and uniquely qualified to solve the problem that no one else is working on. And with that, I'd like to open the floor. Thank you for all my partners we've been here with, and answer any questions anyone has. Thank you.
Judges, in-person judges.
I just have one question. What about economics? Are you able to compete with virgin materials?
Yeah, because of the fact that we don't have virgin raw materials, our price point is average about 50% less than virgin. Right now, we have about a 3T. That includes with collection and processed material. And yes, our finished good price is about 50% go to market than average.
Other question, I think Prem online had the same question, unit economics. Anything else? Thanks, Brian.
Thank you.
Number 3 is up. We have Finite Phoenix and Michigan State University. Roger, are you coming down as well? Or is it all on Ramani? Okay, Ramani Narayan, long time person in the industry that I've known for 30 years, is here to talk about Finite Phoenix and Michigan State University.
How do I start this? So let's see. Up next. Do I go next? Cool. Thank you, Roger. It was good to connect here, JD. My name is Ramni Narayan from Michigan State, and Roger Cargill is from Finite Phoenix. And today we offer 3 innovations, sort of across the board. One is the innovation on plastics. Of course, you've been inundated with the word plastics and microplastics. The second concept there is the emerging new compostable plastics, and how do I provide an infrastructure that can be used to remove that from the environment. And the third one is this enormous food waste issue which we are. And we are fortunate that we have the Henry Ford Health System to provide us the platform to execute this technology. So let's dive deep in. The plastics problem, of course, everybody is familiar with, and I was pleased to be on this National Academies of Science and Engineering report on global ocean plastic waste, which lays bare the issue or problem with this. Now, 90% of the single-use disposable packaging plastics are what I call carbon-carbon backbone polymers. And sorry if I went a little technical, but essentially these are carbon-carbon linkages, which is the most strongest bond we have ever made. And therefore, at the end of life, it's difficult to break down, to recycle or biodegrade, and that's a big problem, right? And so you're left with this persistent, accumulative, non-biodegradable plastics. And so there has been a major effort the last 20 years I've been involved with, was redesign that carbon-carbon backbone with another backbone that is more labile, that I can depolymerize or break it down, and which I can compost or biodegrade. And that has resulted in things like PLA, the world's foremost 100% bio-based biodegradable polymer, which was developed in my lab, and the PhD student's thesis still is the Bible, the reading material for both companies involved in PLA, right? Now, that's one side of the problem and a potential solution. The next problem, which is tied to this, is this biodegradable organic waste. What do I mean by that? Well, 50%, just imagine, 50% of MSW, municipal solid waste, is food, paper, and organic waste. Today, that is contaminated with all these packaging plastics. You just have to look at it, the thin films, the wraps, and all those things. And what do we do with it? We send it to a landfill. Given the environment, the anaerobic environment, this results in a 25x GWP, global warming potential impact. So clearly something has to change in this. And one of the solutions, obviously, is diverting the food waste to industrial composting facilities and manage it so that no methane generations happen. But there's plastics, and they form microplastic. So clearly plastics associated with this MSW, this food waste, has to be also compostable. And therefore, the solution we are offering then is that if you have certified verifiable compostable plastics, and I've been privileged to develop the standards which are the basis for defining compostability and biodegradability, that in conjunction with food waste diverted to a managed end of life like composting provides a circular closed loop system to manage plastics, but also manage the waste stream, right? So that's kind of where we are talking about. And just for numbers' sake, remember that 1 to 1 equivalents. If you divert or recover 1.84 million metric tons of biodegradable organic waste, you would get savings of 1.74 million metric tons CO2 equivalent GHG saving. Dramatic impacts by just switching how we do business. So what is the innovation we are talking about? So we are proposing to use composting, and composting, everybody thinks it's been around forever. So what is innovative about composting? And what we are saying is we are talking about a two-stage model where we will look not only at the food and organic waste, but also the compostable plastics and generated at hospital patient kitchens. You see the conflage of plastics and food, and then compost it in the format we are talking about. So we plan to use a flow composter that would treat this waste. And the Henry Ford system is going to provide us the platform to do that. And we are going to do the research. So the deliverable is actually on a non-profit, scalable, continuous flow composter. It will provide a stable amendment product. It is on site to deal with both plastics and food waste, and therefore solve a problem which exists today. That was 5 minutes.
Thank you.
You guys did it wrong.
Well, good job. Do we have questions for Dr. Narayan?
As a clarification,
Sure.
the harp and vessel compost product, that does not compose traditional plastic materials that carbon bond that you were describing, that you would have to replace the material with the nature tech controlled product.
Yes.
Okay.
So two things your question brings up. One is when we say HARP system, we are saying that it provides the mechanical system, but we are going to develop the chemical engineering principles, which says how much food waste, what would be the residence time, what would be the scale. That's done in the lab, and ensure that the final product is truly a stabilized compost product, which can support both biological activity and plant growth and other things. So it's a very critical to differentiate between the so-called in-vessel composters, the dehydrate. There's all sorts of myths in this space. That's what somehow we are going to go away from, to provide proof of concept that this can be doable in a short time frame and does not need the static windrow type, aerated, non-aerated, where you track everything to a compost system. This would be done right at the hospital kitchen end, where they're directly treated. And then now all you have is 30%, 70% volume reduction, with the waste being now converted to soil to be put in on the ground. So that's a very different approach to what's today practiced.
Thank you. Thank you. We're going to now move on
I
to
should say thank you for the question.
ISAC, which we're going to need you to introduce yourself, because I forget what the acronym stands for. But welcome Ashley and Joe for the next discussion about what they're doing in the world of industrial sewing.
Thank you.
And Ashley and Joe, before you start, I'm going to give you 3 minutes, 1 minute.
Wonderful.
Hello, everyone. I'm Ashley Conley, a program manager with Industrial Sewing and Innovation Center, or ISAC.
And I'm Joe. I'm the sustainability manager at ISAC, and we're here today to talk to you about our project on upcycling textile waste. So ISAC is a nonprofit National Institute for the Sewn Goods Trade. We were founded by a group of industry leaders who had a shared vision to reimagine the future of fashion and apparel through advanced technology and a shift of values towards environmental sustainability and workers' rights. To reimagine the industry, ISAC faces some existential challenges, none larger than a massive amount of textile waste that the industry produces. One garbage truck full of clothes is landfilled every second across the world, meaning by the time that I started talking, this whole room would be filled with textile waste. So within that textile waste problem, there exists a severe lack of affordable, accessible, and regional textile recovery options that can put waste back into the value stream. So your more mature technology is mechanical recycling, but that doesn't provide virgin to virgin level quality. And also for small and medium sized manufacturers, especially within the Midwest region, it's just, there's no accessibility. The future is going to go towards chemical and molecular recycling, which does provide that virgin to virgin quality, but there's scaling issues that hasn't really gone past the lab scale and certainly not to the industrial scale yet. So ISAC really believes that there is an intermediate solution that can help us put textile waste back into industry, and that is through felt. And so our project is creating a micro factory model with a handful of pin felting machines to turn textile waste, cutting scraps or full garments into felted fabric, and then turning that felted fabric into a variety of end products for a variety of end markets, including handbags, home goods, wall hangings, upholstery for furniture, or industrial applications.
We're proposing a 12-month project that will start with purchasing a pin felting machine from Feltloom, which is a proven technology used in an upcycling project by Eileen Fisher. Also within our first 2 months, we'll begin formalizing a circular partner roundtable of end market users, feedstock and textile waste producers, and other industry stakeholders. We'll use our circular partners to begin developing viable prototypes for market, then move into piloting manufacturing for scale. Throughout this process, we will train our production staff and develop a training curriculum to accompany the technology and manufacturing process. At completion, we'll deliver a viable prototype with one secured order and a training curriculum that will accompany a scalable business model. Our total proposed cost for this program is $281,000, of which we're asking our roundtable contributors to commit their time in kind. The funding gap remains at $240K, and as a nonprofit, we will secure this amount in grants and donations. Once the funds are committed, we'll continue adding to our initial list of committed partners and begin developing prototypes. We've seen these market applications for felted products from brands like Gucci and Eileen Fisher and believe there's a unique opportunity for Michigan manufacturers to begin producing this product for market while simultaneously diverting waste from landfills. Isaac is we produce garments and we're a training facility, and we have plans to scale micro factories nationally, as we're already working with clients in a dozen states as an education and technical resource. We incubate product solutions such as this pin felting project that can be deployed nationally. This pilot is meant to validate our initial assumptions and to validate the market for our products. Everything we do at Isaac is for people.
And that's because we believe that to claim to be a sustainable organization, the lives of the people that work for you also need to be sustainable. So we're a leading training organization whose focus is on creating a robust and equitable workforce. So when you partner with Isaac, you're not only partnering to advance industry solutions, but you're also partnering to create the future of the industry workforce with living wages and skilled positions.
As a 501c3, we're soliciting grant and impact investors to close our funding gap and support our mission towards building a more sustainable solution for people and the planet.
Thanks
Thank
so much.
you.
Thanks. Do we have questions, virtual questions or analog questions from the judges in front?
I just have one question. On your proof of concept, you know, you already know your limitations and what the first key target markets you should be focusing on.
To repeat the question, he's asking your proof of concept. Do you know what your how you're going to go about proof of concept and what your limitations might be?
Yeah, so the point of establishing the circular roundtable is to bring in industry partners and people with more expertise within certain end markets to really help guide us through what are the quality requirements going to be, what are the technical requirements going to be, how can you actually make a product that can be consumer facing. And so while we have kind of broad strokes of the industries that we outlined, we really hope that that circular roundtable partnership group will help guide us towards one specific product that can be marketable.
Do we have time for one more question? Further questions? It's all right. I'm going to repeat your question because the table mics aren't working very well.
For the pilot and validation project, what volume of
what volume are you seeking to impact in the validation or pilot project?
So we're targeting with this pilot 500 to 1,000 yards of textiles, which we've averaged based on what we've seen in the market, that being 3.54 pounds per yard. So around 3,500
With one machine.
pounds with one machine, correct.
Thank you very much. The last presentation before our break Jason Wang from Western Michigan Pulp and Paper School, right? There you go, Jason.
Thank you. Good news. I guess I will be the last person who talks about composting today. I'm Jason Wayne from Western Michigan University Pilot Plants. I'm a paper engineer. I'll talk about compostability testing of paper and plastic materials to divert from landfill. I'm sure many of you have heard this, 100% reusable, recyclable, or compostable packaging. This was first mentioned by Ellen MacArthur Foundation in 2018. And after that, more than 60 global organizations have joined forces to work towards this goal. This is great to reduce waste. However, the truth is, among 67 million tons waste paper generated in 2018, 71% was recycled, 26% went to landfill, and nothing was composted. Why is that? First of all, most food soil paper products and bioplastics are not acceptable for recycling. Second, many of these products are self-declared compostable, which were found not completely degrade in industrial composting facility. The only certification designed for compostable in industrial facility is BPI compostable certification. However, currently only 3 labs in the United States are certified to perform this test, and they claim they have received extremely high demand in recent years for this test. Therefore, we propose to create a new testing lab, which will be the first certified lab in Michigan. We will use a highly automated measuring system, which gives us the advantage to provide reliable data in early stage and rapid scale up, which is average 33% increase in testing capacity each year. Our team has accumulated years of experience and great reputation in paper industry by providing workforce, facility, and technical solutions for product development, research, and education. Our great facility includes a multi-layer paper machine, a large-scale coater, and a large-scale recycling facility. We have tested and certified hundreds of paper products from customers all around the world, and we will continue to promote sustainability in paper and allied industry. We also have diverse partnerships with organizations such as Western Michigan University Paper Engineering Department, NextCycle Michigan Program, TAPI, Closed Loop Partners, and many of our existing customers in paper industry. For the market, thinking about the big picture, there are 17 million tons waste paper products and bioplastics, which could be diverted from landfill. However, only 3 labs can certify these products, and they have reached their maximum capacity. Additionally, we have received many inquiries from more than 10 of our existing customers asking about this test, and many of them have more than 3 products waiting for testing and certification. Our current capacity is already filled by all these inquiries to year 3. Therefore, we expect to scale up starting year 4. Our business model is simple. The initial investment is $130,000, including facility, equipment, and materials. We expect to spend $50,000 each year starting year 4 and for scale up, and we will charge a testing fee as revenue, which provides us an estimated payback time of 24 months and a 5-year ROI of 215%. We're in the process of conducting proficiency tests and getting certified with BPI, and expect to start our first commercial test in September this year. Last, we would like to ask for $50,000 to $100,000 in funding to support our scale up starting year 4. And we also look for more partnerships with local business, government agencies, and other research institutions to work together towards a zero waste community and industry. That will be all for my presentation today. Thank you for your attention. I can take questions now.
Thank you. Question from the panel. Would you speak to the business model and how you decide what you're going to charge for the tests?
So unfortunately, our management decided to not disclose our charge testing fee at this moment. But we will charge a competitive fee as our competitors or other testing facilities.
So just to clarify, the unit price for testing will be about what your competitors are.
Correct.
So, okay.
Correct.
So that gives us an idea. All right.
Yeah.
Other questions?
So beyond testing, will you be working with the companies to develop processes to improve the compostability? If not, or is it just you're going to run the test and tell them what material?
The question is beyond testing, will you then provide feedback to the companies to improve compostability if your tests show that they're not quite as good as they could be?
Right. This is a good question. So this testing lab we're building is just for this project. And with great facility and great talents, we believe we can do much more than providing just the testing service. And we have been providing research for product development, consulting for our existing customers as for paper products. So I believe we'll continue to do so.
Thank you, Jason. That brings us to the end of this session, partial session. It's 2:18. Kira, can I get a thumbs up? If everybody's back in the room at 2:30, does that take care of your schedule here? We good on that? We're good on that. 2:30. Otherwise, we're going to come for you. And Bridget and Kira are terrifying.
Speaker's good, so if you wanna.
All right, we're gonna kick off things again. I think some of you, especially those of you online on Zoom, recognize that the LGBT community was getting a shout out there that was perhaps not as functional or as thoughtful as we'd like, and we apologize for that. I guess that's a curse of modern life, to get your Zoom meeting hacked. So I think we've taken care of it, and apologize if anybody got offended, and we're going to move on. So we have 4 more presentations. I have my little cue card here, and we're going to kick the presentation off with Rebecca Hu from Glacier Robotics. I have a feeling, since I haven't seen Rebecca here today, that this is an online presentation. Isn't that right?
That's right. Can you guys hear me?
We certainly can, Rebecca. Good to see you again. And
Likewise.
I guess you have control. Do you have control of your own slide deck here? So we're rolling.
Let's find out.
Okay.
I think there's a little bit of a lag. Can you guys see my cursor moving? I just clicked, but it doesn't look like it's doing anything.
Yep, there should be a small lag, but your cursor is moving.
Okay. Doesn't look like it's letting me go to the next slide, unfortunately. Let's see.
Go down to the bottom left of the screen. There should be the proceed arrows.
There we go.
Awesome.
Okay. So every year we throw $123 billion of commodities into our landfills and our oceans. Now imagine a future state where our recycling systems are so robust that any item that still has value gets brought back into circulation. I'm Rebecca, I'm the founder of Glacier, and that is exactly the vision that my company seeks to solve. We're starting with MRFs, which are materials recovery facilities, and these are the facilities that take in all of your blue bin material and actually sort them so they can be resold as recycled feedstock. Now, MRFs are facing a very interesting business dilemma because on one hand, they're seeing unprecedented demand for recycled feedstock, which is an amazing business opportunity for them. On the other hand, they're having some trouble actually meeting that demand, and this is primarily due to struggles with the workforce. On one hand, of course, labor is always expensive and the cost is increasing. And on top of that, there's a massive labor shortage that is persisting and has started ever since the pandemic. Now, the vast majority of MRFs still rely primarily on manual sortation to achieve this feedstock that they're trying to sell. And so this presents a very sticky situation for them. Glacier is trying to address precisely that demand-supply gap. We're doing this by building a computer vision-enabled robot to automate recyclable sorting. Consider manual sortation. Not only is it very expensive and a very difficult job to hire for, it can also actually be quite unsafe. It's 2 times the injury rate of construction work. On the flip side, when you think about Glacier's robot, it is incredibly inexpensive. It can pick 24/7, so it's very consistent, and it's smart. Because it uses computer vision, it can adapt to and learn from an ever-changing material stream, unlike traditional equipment. Now, robotic waste sorters have been around for a couple of years now, so the market is starting to form, but it is massive and nascent. So when you think about the total future addressable market for just these recycling robots, that's actually $38 billion of annual opportunity, which is huge. Now think about the number of robots that are actually currently installed, and you're seeing less than 2% penetration of this massive market. So some of you might be asking, if these robots are truly such an amazing solution, why isn't every single MRF going out and buying 30 of them yesterday? And we at Glacier actually had the same question before we even started the company. So we went out and talked to the folks who know best, that is to say, MRF operators. And of the several dozen that we talked to, it was interesting because every single one had heard of robots and generally understood the value proposition. But 74% of these operators specifically told us that they are waiting for better ROI. And this is pretty easy to understand when you look at the chart on the right. When you consider the high CapEx cost of some of these other robots on the market, in combination with the fact that it often costs hundreds of thousands of dollars to retrofit your facility to actually get the robot in there, you annualize that cost and it actually ends up being about the same amount that you might pay for a worker to come in and sort on your line. Glacier took that as our design starting point, and we said, we want to build the highest ROI automation, sortation automation on the market. And so what we're doing is we're creating a patented design that effectively reduces the number of moving parts and really simplifies the technology such that we can build it for much less and also offer it to MRFs for much less. On top of that, we're making it much smaller footprint and easier to install so you can get it into your facility with way less time and resources. In effect, we're fundamentally changing the economics of automation, meaning that any MRF, regardless of age or size or budget, is able to implement this type of technology in their facility. Now, Glacier is a pretty new company. We've only been around for 2.5 years, but we've achieved an incredible amount of progress in that time. Starting with our team, we've pulled together minds from some of the top tech companies and universities across the country. On top of that, of course, our participation with NextCycle Michigan has afforded us access to some of the best and brightest recycling and industrials and manufacturing minds in the state of Michigan, and we're really excited to have them on Team Glacier. Our product is in late stage development, and we've actually already completed a high-value proof of concept trial test with an actual MRF. We've been able to achieve significant annual labor savings for this facility, and we also validated several core value propositions of Glacier's specific design, including really rapid installation time. So we went in over the course of a weekend, no downtime for this MRF. We installed for less than $10,000, which is literally an order of magnitude smaller than what you'd see from a typical robot install. And we collected 520 tons of plastic over the course of a year. We're really excited to bring our technology to the state of Michigan. We're starting with a pilot NextCycle project, which will effectively install some of our robots to serve 12% of Michigan population, resulting in annual profit increase, GHG reduction, and targeting key materials. We're really excited for Glacier's technology to be a key building block on Michigan's roadmap towards achieving its really ambitious recycling goals. So in conclusion, if you guys in the audience represent a MRF or a potential strategic partner like a brand, a manufacturer, or a municipality, and you're interested in learning about how you can participate in a future Glacier pilot project, please reach out to me at rebecca@nwaste.io. We would love to speak with you. Thanks.
Thanks, Rebecca. I think we have time for one question. Looks to me like we have not had any additional questions online, so why don't we move to the analog judges here.
Where's your company based?
Where is your company based, Rebecca?
Sure. Our company is currently based in San Francisco.
Okay. That was a short question. We can have another one. Well, then I'll ask a question because I'm very interested in this technology. Tell us a little bit more about your quick install and how you do it, because I think that's a big deal.
Absolutely. Yeah, it's a great question. So in thinking about the install, a couple of components to it. We have really spent a lot of time designing our robot to be as modular as possible. And part of what this means is that we're able to create essentially a design that we can break into parts very easily. They're fairly lightweight, so actually we can do it with no additional equipment like cranes or anything like that. Carry it into your facility and then essentially construct it on the spot where it's supposed to be. And that's how we're able to achieve that really tight turnaround time of less than a weekend.
Thanks.
How small a facility could this deliver ROI for?
Yeah, give us a quick take on what scale of the smallest facility you think this would work for.
Absolutely. This might be a straightforward answer, but we have not yet found a MRF where we don't think that we could fit this robot into. And the reason for that is because we actually took as a design constraint the amount of space that's typically allotted to a sorting station. And that's typically, call it about 36 inches where a person would stand. We've specifically designed our robot to fit within that footprint such that we could conceivably put it in essentially any facility that has room for a sorter to stand.
Okay, thanks.
Mhm.
I have one more question. So
Okay, one more question.
how do you plan on scaling it? What's the unique piece that you bring to it, and how do you protect that? Is there IP?
Do you have IP protection as you scale to make sure that you can control your business trajectory?
Absolutely. Yeah. So we already have a couple of patents pending for the particular design of our robot. And then on top of that, I would say what we found is that actually a large part of the magic of what we're creating lies within the software solutions we're providing. So there are several particularities to our robot's specific design that we have been able to solve with clever software solutions effectively. And so those are not always the most intuitive, but I think they offer us a significant amount of IP protection as well.
Okay, thanks. We're going to have to move on. And at this point, I'd like to introduce Bob Ranger from Polyplastics Technology. Thank you, Bob.
All right, I'm not loud.
Okay, let me see it. Great. Well, hello, I'm Bob Ranger, the CEO of Polyplastics Technologies. Now, I don't know about you, but when I visit my kids, I do not want to see that off their deck or anywhere in their backyard. So I was very happy to see that the state of Michigan and NextCycle are teaming up to increase those recycle rates from 15 to over 45%. To create a circular economy for our children and grandchildren, because we created that problem and we need to fix it. So our company's here to help fix it. That's the good news. After retiring from Dow Chemical in about 35 years in the plastics area, I started a company that helps recover these mixed plastic bales, and then it helps create recycled plastic that Michigan companies can then put into their products. So the solution is to recover polypropylene from these mixed plastic bales, which are mostly polypropylene in the first place. And then when you add the proprietary compatibilizer that's based on MSU technology, you get a nice recycled pellet that has great properties, and demand is much higher than the supply for this post-consumer material. The technology is a patent pending compatibilizer that works with both plastic phases and holds them together. So the solution is to recover the polypropylene using existing equipment. So here's existing equipment for a high density polyethylene milk jug recycling facility. So they buy the bale for 30 cents a pound, goes through the bale shredder, all the equipment, and they extrude a pellet and they sell that for about 80 cents a pound. It's a good business, right? About 30% margin. Then the new polypropylene process uses the exact same equipment, only you buy the mixed bale for 2 cents a pound, so there's no demand. And then you'll notice it's mostly polypropylene and a little bit of 10% or more polyethylene. So when it goes through the exact same equipment, you've got a problem. And the problem is that 90% polypropylene at the end, or there's 10 to 15, 20% polyethylene, doesn't mix. You get no physical properties. It delaminates, you can't make a pellet unless you add a compatibilizer. So that's where we come in. You add the compatibilizer at the extruder, you get a nice pellet. You can sell that for 70 cents a pound. That's a better business. So here's the numbers. You buy for 2 cents. You add a little bit of cost, you sell for 70 cents, that's about a 40 to 50% margin. So the bottom line is the value for the reprocessor in Michigan is they can sell a new product line of recycled polypropylene that's post-consumer at a profit. The technology works. The 90-10 mixture that I showed you on the previous slide loses 50% of its tensile elongation property. However, if you add our additive at about the 2% level, the properties all come back. You can see that on the far right. And our solution works better than other competitive compatibilizers out there or additives. And there is high sorting. There is high expensive sorting equipment that can be used, but it takes about $1 million in capital to get started. So the market size in the United States is about 16 billion with a B pounds of polypropylene that's landfilled. That's according to the EPA. So here's our compatibilizer revenue if we get 10% share and recover 10% of the polypropylene from landfill in the United States. We'd have a $100 million business. If we only focus on the state of Michigan with 10% share, we'd have $4 million in revenue. And on the far right, you'll see there's lots of examples. That's just a small set of polypropylene recycle applications in Michigan. There's many, many more. So the demand for this recycled polypropylene that's post-consumer is 5 to 10 times the supply. Okay, so the brand owners want to use this recycled polypropylene in all their products. And so it's a great market opportunity. And emerging opportunity is multi-layer packaging is all going to need a compatibilizer as well. The business model is we're going to make the compatibilizer to contract manufacturer, and we're going to sell the compatibilizer directly to reprocessors at about $2 a pound or so. And at a 2% usage rate, that will add about 4 cents a pound to their cost. That's easily absorbed. We're going to make about 60% margin. And more importantly, the Michigan customers will make more money by selling more recycled pellets that are post-consumer. And we've already had 4 customers so far ask us for samples. So that's great news. Our go-to-market strategy is phase 1 regional scaling. We'll sell to the direct plastic processors in Michigan. There's some examples of some of them. Phase 2 is national scaling. Now, not all 240 of these processors in Michigan, there's several per state. Not all of them are going to be interested, but I called one customer outside the state of Michigan and they already said we'd like a sample. So that's great news. Milestones. We have a milestone plan, but most importantly, like I said, we've got 4 customers that already requested samples. And one on the far right, I love this quote. He's super interested in the mixed plastic bale to pellet economics. So our initial funding that we received has gone through the lab work and customer discovery. In the middle there, you'll see we're planning on focusing on customer sampling and applying for $50,000 in funding in March to get to our MVP, which is that first robust product. And then we're going to do regional scaling and national scaling that will require $150,000 from either the Polypropylene Coalition or Closed Loop. So that's about it, JD. So we have a wonderful team of myself and Mohammed Rabnawaz from MSU is an expert and a great group of advisors as well. So thank you. I'm ready to take your questions.
Thanks, Bob. Questions? Bob, can you talk about the CapEx, please?
Oh, there's no, oops, I was trying to go to my backup slide. I had a financial slide. No, there's no capital required. It's contract manufacturing. Okay. And it's easy to implement, easy to scale up, falls into existing equipment. And we do have competition with the polypropylene sorting equipment, but we feel only the large MRFs are going to have the capital budget to do sorting. All the small and medium-sized companies are still going to make bales and they're going to have to sell them to somebody. And that's where all the small, medium processors who will be our customers will come in.
Other question?
What you had on that slide, is that examples?
Yes.
Are those like potential partners or are those actual partners?
I've talked to most on the left and the right here. I don't want to go into specifics, but we've already had 1 on the right and 4 on the left that want to take samples.
So what TRL would you classify the
What what technology readiness level are you at for if we use the DOE or DoD scale of technology?
So have you tried it outside the lab on the old like?
No, no, it's a great question. So we're still inside the lab. So we've completed proof of concept. You know, we can make about a pound right now. So we're behind what the customers are asking for, but that's a good problem to have. So I want that problem. But the physical properties look good because they all come out like looking like they're polypropylene. And when you add polyethylene, for those of you who are material scientists, the impact properties actually go up. So some of the properties are higher.
One more question.
Just the status of the IP.
What's the status of the IP?
Yeah, we filed a provisional a year ago. We just filed the utility patent in February, and Polyplastics is in the process of negotiating an exclusive license with MSU to option and evaluate it.
Okay, thank you very much. And good questions. Next up is Raju Patil and Pivot Materials. The stage is yours. Thank you. How do we start? How do we start? How do we do that? Is this the clicker for next? Okay, okay. 500 billion tons of agricultural waste is generated each year. Most of it goes to either landfill or burn, creates more pollution. Heavy Metals is a clean tech company where we take this leftovers or agricultural waste or industrial waste and use it to some useful materials and create alternative to traditional plastics. Our main mission is to reduce the greenhouse gases and reduce the use of synthetic plastics and use natural materials as much as possible and avoid them from going into landfill or getting burnt. We are off to a new problem solving. 250 million pounds of paper waste is in terms of byproducts are generated each year. Some of it is toxic. And when it is, if it is leached into the waterways, it can pose hazard to the aquatic life or animal life. We are in a position to take this material and convert it into useful products, as we have done with some other waste materials. We have the proprietary technology to blend these waste materials into either synthetic polymers or biopolymers. Biopolymers as of now are very expensive, ranging from $5 to $25. We can upscale these waste materials and bring the cost down of biomaterials to a comparable and cost competitive to the traditional or synthetic plastics. So far, we have developed our materials are recyclable, they are stronger, and they can be reused. Pollution affects everybody, but it affects more to the low income areas. So we are planning to work with the low income hub zone areas where we can make the maximum impact. This chart shows the main activities that we are proposing in this plan, starting from how to extract the fibers to how to design the new products and finally the applications. We estimate around 8 months for this project from start to finish. The task, the horizontal bars indicates the task and its duration, and the color coding indicates the risk associated with each task. This is a summary of the budget, how we plan or intend to use the funds for hiring, testing, and prototyping. The plastic industry is around $280 billion, and we are targeting $30 billion as our opportunity in packaging, furniture, home and houseware, and agriculture. One of our customers has already expressed interest in using these paper fibers to develop a biodegradable containers for their agricultural applications. We work directly with the manufacturers, brand owners, and some distributors, and we generate our revenue by selling our materials to these brand owners or manufacturers. And this model has worked very good so far for us till now, and we'll continue to use this model. We are a team of 4, but we have a combined experience of over 70 years. And we have experience in polymer science, plastic engineering, and manufacturing and sales. Great Lake Tissue generates over 60 tons of paper waste every week. Considering Georgia Pacific and international papers, probably 100 times more than what Great Lake Tissue generates. And that's our raw material. We are also working with Kettering University in Flint, where we are trying to develop a technology for these paper fibers to convert into useful materials and finally some applications like these containers and the non-food packaging applications. We're looking for opportunities for funding in terms of grants, angels, or VCs, where we'll use these funds to test, prototype, and hire new staff members. And then we prepare for manufacturing after that. We have successfully developed other waste materials like bamboo, rice, coffee, and almond hulls. Now we are up to build up on that success
to convert the paper fibers from a local stream in Michigan. And there are other waste streams in Michigan like cherry, potatoes, and develop the waste stream and generate new materials here locally in Michigan. Thank you.
You earned the brevity award. Very nice job sticking within your 5 minutes. We have plenty of time for questions. We have Prem is interested in a higher, a more granular overview of revenue to date and the next couple of years as you scale up.
This is the new project we are developing for waste from the paper waste. We don't have the actual revenue for this product, but we have revenue for the other products that we have already developed that are already commercialized.
So just to clarify, your business, this is a new innovation within an existing business.
Yes, we're building upon what we have already developed, the proprietary technology, and use it to develop the paper fibers from local sources.
Okay, thank you. Questions? He's going to go back to the milestone timeline. I think Jennifer has a question about the milestones. Where are we now on this timeline?
We are in the start phase. What we are doing is now starting now to develop that one based on our current technology.
One more.
So why was the source from a tissue plant? Isn't that the most compostable and recyclable material?
Question is why is one of the sources identified a tissue plant that has one of the most compostable residual components coming out of it?
The paper is all made of plant waste or plants. Those are from the trees, softwood trees, and they are naturally biodegradable. So when we put it into biopolymers, they can biodegrade naturally along with that one or compost it with that one. Was that the question?
I think that was the question. Thanks. Let's, thank you very much.
Yeah.
That was excellent. And finally, with the last but not least pitch of the day, we have Madeline Miller with NextCycle. The floor is yours.
Thank you. Is this how I'm changing slides? Maybe this one.
Bridget, we need technical help.
Do I just, now I can do this one or this one?
You can do, yep, that one.
Okay, thank you. Hi, everybody. My name is Madeline Walker Miller, and I am the founder of NextCycle. NextCycle is a Detroit-based textile recycling company that specializes in diverting pre-consumer manufacturing waste from landfill. I started this journey in 2019 as a student at the University of Miami School for Marine and Atmospheric Science with no real marine science background. And I worked to wrap my mind around this idea of microplastics and other materials that were plaguing water bodies and oceans. In the process of this, I became aware of the major contribution that the apparel and automotive sectors make to landfill waste, and that is how NextCycle was born. To give context around how much waste is landfilled, globally, 80% of textiles are doomed for landfill or incineration at end of life, and landfill textiles can take up to 200 years to decompose. During this decomposition process, the fibers leak harmful chemicals and dyes that on one hand contribute to landfill gas and on the other hand contaminate our soil and water resources. And the worst part about this is that textile consumption is expected to increase 63% by 2030. NextCycle is a part of the solution. So our model is that we pick up textile waste from local fashion and automotive manufacturers, and we are working to convert that waste into low dust, eco-friendly building insulation. Our process is shown a bit on this slide. And so an industrial shredder is used to convert the collected automotive foam, in this case, to loose fill insulation. And so the input is a molded automotive foam and the output is a shredded material comparable to a blown in cellulose. And our minimum viable insulation product is just that. It is a low dust shredded automotive foam to be used in wall cavities, attic floors, and ceilings. And we're really excited about this because insulation is the most cost-effective recommendation for reducing heating and cooling bills and slowing greenhouse gas emissions. The US building insulation market is growing, and the reasons for that are that building codes are becoming stricter. So structures are requiring more insulation, and retrofitting is at an all-time high, retrofitting to slow greenhouse gas emissions. And so NextCycle is looking to capture a really small portion of the US single-family housing market with our product. And this is also exciting for us because President Biden's clean energy plan includes weatherizing 4 million commercial buildings and retrofitting 2 million homes, which will create at least 1 million good paying green jobs. And so for us, this means that in the near future, using textiles and recyclables in building and construction products will become the norm. And so the Midwest is a really good area to market this product to. It has older housing stock than much of the country. And in Detroit specifically, 60% of the city's housing stock was built before 1970, which poses a really good opportunity for insulation upgrades. We are aware of several competitors that produce a insulation product that they market as sustainable. However, when we bring our product to market, it will have the highest content of recyclable material, and we are confident that we'll be able to secure all of the certifications on this slide, plus others that we are aware of. In terms of our revenue model, we sell textile waste pickup services to local businesses for up to $2 a pound, depending on where a business is in relation to our warehouse. And we're looking to sell our insulation at a target price point of $1.40 per square foot. And we're really confident in that because right now we are receiving our feedstock at no cost. This month, we will focus on ASTM testing to bring the product to market, starting with E84, which is a flame spread test. We look to purchase a small industrial shredder to process our regular client waste and our new automotive feedstock, and to ultimately launch manufacturing at the end of the year. And we're looking for $100,000 to do so. So here's a breakdown of the costs associated with us purchasing equipment, training our textile waste specialists, and starting a pilot manufacturing run. And that is all for me. I thank you guys for listening, and I'll open for questions now.
The other one coming in under time. I think they're gonna have plenty of questions for you. So you can leave your mask off.
Okay.
I think we have a question online. Bryce, can you tell me what's going on?
Yeah, could you speak to any regulatory or EPA burden to get this market?
Yeah, the question is, could you speak to regulatory or EPA burden for getting this to market?
Right now, we can't speak to any regulatory burden. I think we will have a much better idea once we complete this round of standards testing in March and find out if the insulation will require any additional coatings or treatments. I think that'll give us a much better idea. But the fact that the material is already flame treated and used in cars is really promising.
Good observation. Yeah, we have down there.
Yeah, so you answered my first question. So the source of material is inherently flame resistant. But what about from just a pure insulation or R factor? Is that what you're having?
What kind of R factor do you think you're going to get from this?
Well, in the shredded denim product that we tested before, we got an R19 estimate for that. And the consistency is similar, but we won't have an official R factor until after this month.
Dan?
Do you have partnerships currently in place to take advantage of near-term opportunities from the state of Michigan, the federal government, Justice 40, building out from Detroit and elsewhere as a small business?
He's asking about specific partnerships with the federal government, state of Michigan, city of Detroit for building out small businesses.
Maybe like a Walker Miller or something like that.
Like Walker Miller.
Well, Carla Walker Miller is my mom, so we have we do expect to partner. We're going to partner with Walker Miller Energy Services on the pilot later in the year where we install the product into wall cavities of actual homes. So when we did our initial round of customer discovery, she was kind of the bridge between us and different contractors that are doing similar installs.
Any more online, Bryce? No, any other questions from the judges? Well, thank you very much.
Thank
Madeline,
you.
that was excellent. Thank you, everybody. Matt had some parting words for you.
Thanks, JD. That was great. Governor Whitmer and Eagle Director Lisa Clark have set the clear pathway to making the connection between materials and recycling and climate. And I was really happy to hear that connection that we're stepping up and we're meeting that challenge with these teams. I'd love to hear those connections that were being made.